Hello folks, today we're gonna talk about probably one of the most popular airfoil database called Airfoil Tools, which is an amazing website, and you have almost all type of airfoils available worldwide, starting from something really classical and finish with something unique, some strange airfoils which you might never use actually in real applications. As you remember, in a previous video we covered NACA airfoils, specifically 4-digit airfoils. And on this website you've got a huge database of all the NACA airfoils, including here you see the 4-digit airfoils, 5-digit, 6 series, all of them grouped. And you can go to searching them using, for example, a name or maximum thickness or various parameters, or even group them in a different way. But one of the most useful thing on this website is actually airfoil generator. Here, if you have a look, that's a NACA 4-digit generator, which basically generates the airfoil based on its parameters. Down below here, you've got all the mathematics behind the NACA 4-digit airfoil. And as you see, you've got a few parameters here: max camber position, thickness. All of these we already covered in the previous video. And the number of points. So let's go through all of them. The max camber, as you see, it tells 2% in this case. So we actually have, because of this, a 2 here. Max camber position 40%, because of which we have 4 here, if you remember from the previous video. And the thickness 12, because of which we have the last 2 digits of the airfoil, 12%. So as soon as you change it, for example, 0, boom, you've got another airfoil. Let's bring it back. Let's say not 2, but like 3. And automatically it stands for the 10 here. And now that's a NACA 3112 airfoil. But if you change it, let's say to 50, for example, you've got NACA 3512, which is another airfoil. Same with the thickness. If you make, for example, instead of 12%, you make it 10%, you have 3510. And the airfoil is changing, obviously. Except that also points describing the airfoil are changing. Here you have it, a dot file, and number of points dictate how many points you're going to have in the dot file. For example, here now by default it's 81. If you put, let's say, 100, you're going to have 100 points describing this airfoil. And this is the classical way of describing airfoil using that file. The idea behind is that it's not any kind of dimension, it's a coefficient. Let's say 1 equals to, let's say, 100%, and 100% of the length as an x coordinate and the y coordinate. And by this ratio it goes from the highest x point, goes to the front here, then goes to the bottom surface. So it starts from upper surface, goes to the bottom surface. Some way you're going to notice it changes. It comes here to zeros. You see here zeros, so that's this point. And all the points before 0 are describing the top surface, and all the points below the 0 are describing the bottom surface. So it starts from the tail, from the trailing edge. It comes like this and goes back. What else you can do with this airfoil? First of all, The DAT file is useful for XFLR5, the software mostly we're going to use for aerodynamic analysis in 2D and 3D. And except that, you can send it to Airfoil plotter, where now you can give actual dimension to this airfoil. So the chord length, for example, you're going to have by default 100 millimeters, and you can write whatever you want, let's say 250. And boom, you have this. You can have thickness here, which is the 100%. It's basically the 100% thickness of the original airfoil, which was given initially. This one, which we started to plot. If you change this thickness, it means you're basically going to change the airfoil. So it's not going to be anymore actually NACA 3510, it's going to be something else. And you can give some parameters here as well. Change, for example, the pitch if you want to have angled your airfoil, to have some kind of angle of attack. And this airfoil you can download in the most cases useful CSV file of coordinates. It is an Excel file which is super useful for working with CAD software. When you want to import your airfoil as a spline into the CAD software, you're going to use this format, CSV file of coordinates. I'm going to make a separate video about using different formats in different software, both CSV and a DAT file as well. And also in a separate video, I'm going to touch this part of the website, Reynolds number calculator, which is super useful thing. I'm going to make a separate video about Reynolds number, describe what it is, how it's calculated, and how you can use actually this Reynolds number calculator here. Thanks for watching. Please subscribe.